Now, there are two main features of RNA that distinguish it from DNA. The first is that RNA uses a different nitrogenous base attached to its nucleotides called uracil, or U, instead of thymine, T. The second distinguishing feature is that RNA is typically single-stranded, unlike DNA, which you normally see two strands in a helix together with each other. But even though it's single-stranded, it's still composed of nitrogenous bases, just like the DNA deoxynucleotides are. So this means that RNA also has the ability to base pair. In this case, uracil behaves in RNA like thymine behaves in DNA. And so uracil binds with adenine the same way that thymine would bind with adenine. So hopefully you'll notice that based on the chemistry alone, RNA and DNA are very similar. And there are just a few differences that distinguish them. Chemically speaking, these differences are very important. And again, out of the scope of this course, you may find out later exactly why DNA and RNA are so different and why their functions can vary so much. I want you to see if you can tell me which one of the following images do you think best represents RNA as it is most likely found in the cell? Do you think you'd see a single strand of RNA just as a straight linear strand all laid out like this first option? Or do you think you would see something that looks like this, where the single strand has folded back on itself in certain areas where it appears there may be some base pairing? Whichever answer you end up picking, I'd like for you to try and justify your answer in the text box here, explaining why you think the RNA would look like that inside a cell.